Hello, welcome to Saturday's edition of Cracking the Cryptic. We're going to have a look at the Deadly-rated Killer Sudoku today. Nice to see a couple of new puzzles from the Times, these quintagrams. Recommend having a go at them. I mean, they're just very quick coffee time puzzles really, but quite nice and always good to see a new puzzle type. So without further ado, let's have a look at this killer. As usual, what I'll do is I'll sort of try and highlight as we go along the logical path that I'm thinking about, and I'll start by putting in some of the obvious answers. So like this 4 can only be 1, 3, obviously in 2 cells, and look, there's a 3 here. So in fact that gives us a number. This has got to be a 3 and this has got to be a 1. Right, what can I see immediately? This number we can identify. So again, if you've not watched any of these videos before, we know that all of the rows and columns and 3x3 boxes in a Sudoku will contain the numbers from 1 to 9 exactly once each. So we know that every row and every column and every 3x3 box will sum to 45. So if we look at just columns 8 and 9 here, you can see we know these two columns are going to sum to 90, but we have a lot of cages entirely contained within these two columns. So we've got 9, 31, 52, 56, 64, 84. So this has got to be a 6 in order to make sure these columns do sum to 90 overall. And then you can immediately do a bit of arithmetic. Probably we've got 21 box here and an 8 box, that's 29, plus this 6 box is 35. So we know these 3 numbers here have to sum to 10 without using a 6. So there's still a couple of ways that can be done, but I suspect at some point that fact will be useful. Similarly, if we look at column 9 here, we've got 22 plus 4 is 26 plus 10 is 36. So we know these two cells have to sum to 9. I'm almost tempted to write in the options for that, because with the 1 and a 3 here, there are only a limited number of possibilities. So those possibilities are the only options there. And of course, this cage here will mirror whatever goes into this, because this is actually a 9 cage. Okay, so what can we see now? I suppose the most obvious thing is we can use exactly the same trick to identify this number here, this time using rows 1 and rows 2. So here we've got 15 plus 21 is 36, plus 22 is 58, plus 14 is 72, plus 9 is 81. So this cell here has to be a 9. And once you get a 9 in it, there's always going to be a 9 in a 22 box, but the other two numbers are going to be limited. It's either going to be 9, 5, 8 as the other possibilities, or 6 and 7. And because there's a 6 here, actually this becomes a little bit more restricted, and it's nearly but not quite useful, that. Okay. A few interesting things I'm seeing here in the grid actually. So let's have a look at this box. We can use the 45 principle on this box. We've got 22 plus 15, so that's 37. So we know these two cells here are going to sum to 8, and therefore these two sums here, these two cells are going to sum to 13. And that means that a lot of this box is going to be used up. With this 13 here and this 22, that's going to be 35, which means that the other 4 cells in this grid have to sum up to 10, and they're all in the same box. So in fact 10 in 4 cells can only be done with the numbers 1, 2, 3 and 4. This 6 obviously can't take a 3, so that's got to be 1, 2 or 4 here. Okay, then we can work harder with the this 1, 2, 3, 4 combination we've identified, because if we look here, we have a 1 and a 2 in this central 3 by 3 box, and we have an 8 here. Now, an 8 in 3 cells has to contain a 1. Clearly that 1 can't be here. So the 1 is in one of these two positions. Now, that being the case, that can't be a 1, and that can't be a 1. And now this 6 is forced to be a 2, 4 variation, and that's really nice, because now we can eliminate 2 and 4 from these two positions, and now we're left with 1 and 3. Therefore this has to be a 4, like that, which is quite nice. We can also remove the 3 from up here, look. And the next thing I'd be tempted to look at to make quick progress is this huge cage here, which sums to 35. So those of you who are familiar with doing Kakuru will know that 5 cells in this sort of puzzle can only add to 35 if they are exactly the numbers 5, 6, 7, 8 and 9. Now I think that's going to be quite helpful. It won't be helpful if I type it in wrong, but if we just type 5, 6, 7, 8, 9 into these boxes here, and see what sort of restriction that places on this bottom 3 by 3 box here. So, for example, we can see we still need to find some room to place a 1 and a 3 in this box. But look, there's a 1 and a 3 here, so these two cells can't take a 1 and a 3. So the 1 and the 3 have to be in the central row here, or central column here. It has to be in column 8. And that does a whole load of things to break this puzzle open, because now if we have a 1 and a 3 in these three positions, that means that up here the 1 and the 3 by simple Sudoku logic have to appear in column 7. Well, they can only appear in these two positions here. So this has to be 1 and 3, and therefore this cell has to be a 4 in order to ensure that this box adds to 14. What's more, if the 1 and the 3 were both in these cells, you can see this cell couldn't be filled. This cell would need to be a 6, which is impossible because of the work we did earlier. So we know that this cell here is either a 1 or a 3, which means that this is a 5 or a 7. And luckily we can't quite tell which way round that is yet. And there are some other obvious things. This 22 box, we know a 22 cage in 3 cells has to contain a 9, and look, we have a 9 here. So in fact this has got to be a 9. And now these two cells are either going to be 5 and 8 or 6 and 7. Well, again, we've got a 6 here, so this has got to be 5 and 8, like that. Now because we've got a 4 here, this has to be a 2. Let's fill that in while we can, and that's very helpful because this 9 box is now, this can't be a 4, 5 variation, it has to be the 2, 7 variation. Oops. And if this is 2, 7, I think we said down here this has to be 2, 7 as well, so, like that. And we know that one of the other digits in this is going to be a 1 and a 3. So what can we say about that? Not quite enough yet, but we're getting very close to resolving this box. And up here we know these two cells here have to be 6 and 7, just they're the only things they can be, and that means that top cell there is a 6. That's a 7. Okay, this cell here can no longer contain a 7. So this can't be a 6. So this is a 5, 8 variation, which means this is a 5 and an 8 here. And now we've done the work we needed to in order to eliminate the possibilities for this 10 cell here. This 10 can be, obviously it could be 1, 9, well that's ruled out by this 1. Could be 2, 8, well that's ruled out by this 8. Could be 3, 7, that's ruled out by this. So we know now this is a 4, 6. Let's put that in. That means we can remove the 6 from all of these positions. Okay. We can see some other things here as well. You can see immediately that in order to place an 8 and a 9 in this 3x3 box here, there's no way they can go in either of these positions because this will then be unfillable. So we know that the 8 and the 9 in this 35 cage are definitely in one of these 3 cells. Therefore they can't be in either of these cells. So we can eliminate them. There's lots of ways of making progress from here. I think if we look, we know these 2 cells had to add to 8. Well, can't be 2 and 6, and can't be 1 and 7. So these 2 cells are 3 and 5 in some order. And that's very helpful because this 22 box now has to be a 6, 7, 9 variation, which actually we could have seen anyway from the other 6 numbers we already have in row 3. Okay. So we can now see that this, the only place we can place an 8 is here in this top 3x3 box. And this is 1, 2, 4 in some order, which means that this cell here has to be a 3. Now, remembering what we said about the fact that there was a 9 in one of these 3 positions, and there's a 9 here, so we know there's a 9 in one of these 2 positions. So note that down, just because that's helpful in terms of, we know this is only a 5 or an 8. Now, if this is a 5, then the other number would have to be a 7 in one of these 2 positions. If this is an 8, it would have to be a 4 in one of these 2 positions, which could only go there. And we can immediately ask ourselves, where can I place an 8 in column 8? Where can I place an 8? Well, you can see there's that possibility, that could contain an 8. But the work we did earlier told us there cannot be an 8 in either of these positions. If there was an 8, both of these cells would have to be a 1, which is obviously impossible. So this is the only candidate for an 8 in column 8. Let's put that in. So, I mean, that's now means that this has to be 9 and 4. This has to be 5. This has to be 8. What can I see now? Okay, here's a complicated way of making progress. You know, I want to, on this channel, show you some of the most advanced ways of thinking about it. Well, let's have a look at the middle row here. We've got 1, 2, 3, and 4. So we know this 11 here could have a 5, could have a 6. Can't have a 7 because then there would be a 4 here. Can't have an 8 because of this 8 here. So the only other candidate would be a 9. But we're going to see that's not going to be possible. So this would be 2, 5, 6 would be the other possibilities here. Now, why do I say that it's not possible for this to be a 2? Well, we can do a little bit of arithmetic to prove that to ourselves. So we can see in this column, in column 1 at the moment, we have an 11, a 6, that's 17, and a 12, that's 29. So we know these 3 cells here are going to have to sum up to 16. We already have an 8 in, so these 2 cells are going to have to sum to 8. Therefore this can't be a 4, and this can't be a 9. We're left with 1 and 2 here. Now you may say, well, I still haven't resolved anything then, but actually we have, because think about this 6. This 6 here, it'll either be a 1, 5, or it'll be a 2, 4. And therefore we know with certainty that the other 1 or 2 in column 1, so there's this cell could be a 1 and a 2, and then we know that exactly one of these two cells will also be a 1 or a 2. Therefore, this cannot be a 2. If this was a 2, this would be a 1, and you couldn't fill this 6. So this is impossible. This has to be a 2. This has to be 5, 6 now, and you can see that allows us to write a 7 into this cell. And it allows us to make other progress too, I think. Let's just tidy that up. So as this contains a 5, this 6 now has to be 2, 4 in some order. Can't be a 1, 5 variation. Therefore this has to be a 1. Like that. And now this 12 here has to be 3, 9. And then other things we can see. We need to place a 2 in this box. Well, the only place a 2 can go is here. Therefore these two cells have to sum to 12. Well, the only possibility left now is 5 and 7. Let's fill those in. That resolves this box over here. This has to be a 6, this has to be a 5 now. And we're left with 1 and 3, these two positions here, which is extremely helpful total. Why do I say that? Well, it's because these two cells therefore have to be 8 and 9 in order to make this box add to the right number. That means these two have to be 6 and 7. And now these two have to sum to 10, but without using 4, 6 or a 3, 7 combination or a 2, 8 combination. So these two cells have to be 1 and 9, therefore this has to be a 1, this has to be a 9. Okay, that means this is resolved. This becomes a 3, this becomes a 5. This has to be a 6. Let's see. 6, 7, 6. We can now remove 6 from all of the other cells in this 35 cage. This 8, this has to be 8 now. This has to be 5. Still need to find a place for a 3 in column 6. Well, that can only go here now, so that's a 3 and that's a 4. That means this is a 3 and this is a 9. So that'll be a 9. These two cells have to be, what's that going to be, 3 and 8 in some order. 3, 8, 3, 8. These have to be 2, 4, 7 in some order. Obviously this can't take a 2 here, otherwise this cage would not be fillable. Can't have two cells adding to 18, so it's got to be 4 or 7. It's got to be 2, 4 or 7. And you can see we still need to place a 1 in column 8. That's got to go in the 10 box now. Well, if this 10 box contains a 1 and the other cell is a 2 or a 7, then we know that this 10 box is made up of a 1, 2 and a 7 exactly. So we can write that in like this. And that means that none of these cells can be a 7, which means this is a 7. The result's a bit more up here. That. Okay. And we can use a quick bit of Sudoku logic to show us something about where the 7 goes in this 3x3 box now. So you can see we've forced the 7 in this box into row 9. It's in one of these two positions. So interestingly, we could use uniqueness to tell us something about this. I'll talk about that in a second. But 7, 7 here, 7 here. Therefore, we know the 7 is in one of these three positions, but it obviously can't be in this position. Can it be in this position? Well, if this was a 7, we know this would be a 4. Therefore, this would have to be a 9. Well, that's not possible because we already have a 9. So we know this isn't the 7. So this has to be the 7 here. This is a 7. That means this is a 1. Which resolves a load of stuff up here. Let's just fill that in, and I'll go back to talking about uniqueness. Okay, let's just go back over here. Imagine we didn't have this 1 in the grid, and we were looking over here at these three cells. Now, if we look up here at the top, we have 2 and 7 in these two positions. I want you to imagine that this cell was the 1. Okay, if this cell was the 1, this cell would have to be a 2 or a 7, this cell would have to be a 2 or a 7. Now you can see this pattern of 2, 7, 2, 7, 2, 7, 2, 7 is impossible. And the reason I say it's impossible is there would then be 2 solutions to the puzzle. Because either this would be a 2 and this would be a 2, this would be a 7, this would be a 7, or vice versa, this would be a 2 and this would be a 2, 7, 7. And the puzzle would therefore, you cannot resolve those from the information we have. Now, the Times doesn't tend to publish bad puzzles. All of the puzzles that you see in the Times will only have one solution. And therefore, we could actually use this uniqueness logic to tell us it's impossible for this to be a 1. Even if we ignore this 1 over here on the left-hand side of the screen, this cannot be a 1. If this was a 1, as I say, the puzzle has 2 solutions. So this has to be a 2. It's the only other opportunities, which means this is a 7, this is a 1. So that's another, I suppose, of these more esoteric techniques that you sometimes come across, which can help you really make progress. And you can use simple arithmetic on the row 9 of the grid now to resolve this square. So we know we've got 13, 22, plus 7 is 29, plus 8 is 37, therefore this has got to be an 8 in order to ensure that the row adds to the right number. And we've got, what have we got, 2, 5, 6 into these positions, and I can't quite see which way around that goes yet, irritatingly. When you get these huge, really high total cages like 26, it's always worth just having an idea in your mind as to how you can make 26. In particular, having in your mind how to make 26 if you don't use a particular number. So for example, if we don't use a 9 in this cage, then you can see that to make 26 is only possible in one way, and that would be if the 4 numbers were 8, 7, 6 and 5, which I think adds to 26. Yes, it does. So if this box does not contain a 9, it must contain a 7. But you can see immediately we already have a 7 here, therefore it cannot contain a 7. Therefore it definitely does contain a 9. And why does that matter? Well, you can see we need to place a 9 in this cage somewhere. There's no 9 here, so the 9 has to be here, which helps us over here resolve a little bit more. This then has to be a 6 or an 8. This has to be 4, 6 or 8. And again, a quick bit of arithmetic on this 20 box is now quite helpful. If you're just thinking about the fact this 3 by 3 box here, we need to place an 8 in here somewhere. Well, the only 2 candidates would be here or here. So we know this 20 box is going to contain an 8. And once we put an 8 in this 20 box, you can see that the other possibilities would be a 4 or a 7. Well, if this was an 8, for example, and this was a 4, then there would have to be 2 8s in these positions. Well, that's clearly not possible. So immediately we know this actually has to be a 7. We know that there will be an 8 in here, and then the other number has to be a 5. Well, there's no possibility this is a 5 because of this 5. So this is an 8, and this is a 5, which means that this has to be a 5. And all sorts of things are going to be obvious as a result of that, I think. This now has to be a 6, 4, 6. 4, 2, 4. Now these two numbers have to add to 10. You can see this can't be a 3 then, because that would make this a 7. So, oops, this has to be an 8, this has to be a 3, this has to be a 2, this has to be an 8. solve this 8-9 now. The puzzle's obviously solved. There's a few interesting things today though. I hope this was a useful run through of, it's probably the hardest killer Sudoku that you see in the daily broadsheets in the UK, so it's always good to run through them, and thanks for watching.